All right, so for page 1, this is part of the calculator section. You are using this function to complete parts A through F. And it says for part A, does the graph open upward or downward? Explain how you know using specific evidence. So it's going to open downward. Okay, you know that by looking at the A value. So explain how you know. Okay, so you can say because A equals -1, and since you can say it's negative, you can say since it's negative, or you can say A is less than 0, the graph opens down. Okay, the main thing I'm looking for with that one is you're identifying the A value. So if you just want to put a little note there, that's what I'm looking for. Okay, don't tell me that x squared is negative. X squared is not negative. It's the value in front that's negative. Okay, so when I'm checking that, if it's upward, then the A value would be positive. So you can say A would be if it was positive, and then since it's positive, the graph opens up. If it's negative, then the graph is going to open down. Okay, for the next one, it's the axis of symmetry, and then it says label it on the graph. Okay, so when you are doing the axis of symmetry, this one we're picky about because the axis of symmetry is aligned. If this is a line, you have to have an equation for it. So your equation is the opposite of B over 2A. So that would be 2 over 2 times -1. On the line, you need to have your x equals. So I want you to write that in right now, your x equals. If you just have -1, understand that you're going to be missing partial credit on that. So the reason why is because it's a line. Okay, so you need your x equals. For the other ones where it's x equals, you're solving for x, and that's different. Usually when you have an equation of a line, what does that look like? What's our standard equation of a line? Yeah, the slope-intercept form, right? The y equals mx plus b. Okay, the only difference is for the axis of symmetry, it's a vertical line. So vertical lines have x equals. That's why you have to have it. That's why I care. Okay, it's because it has to be an equation. Okay, and then once you find your axis of symmetry, that's going to go in the center. Is that blurry for you guys, or can you see that? I try one more time. All right, that looks good. Okay, and then like I said, this is your calculator section. So if you want to, from there, you can go to your y equals, and you can use your graphing calculator to help you with the table. Okay, so once you plug that in, you don't even have to graph it. I'm just putting my back to my standard window. Okay, then you can use your table. Oops, my table is still in a different setup. So your table start, I'll have it start at 0. Go by -1s. Okay, so, whoops. Just have it go by 1s. Okay, and then at -1, you're at 4. That's going to be your vertex. You have -2, -3. So I'm fine with you using this. Okay, for your values. Okay, and then on this side you'll have 0, 3. You'll have 1, 0. And then if that doesn't span the whole grid, then we're going to continue it. So you have -3, 0. You have -2, 3. You have -1, 4. 0, 3, 1, 0. Okay, so I'm going to keep going so I can see at 3, or sorry, at 2 I'm at -5. Okay, so that would be here. And then do you see how the next one is off of my grid? So I'm not going to do that one. Okay, so your table has to have at least 5 points on it. And then it said that you have to label that on the graph. So we're going to go ahead and label that. So your axis has to be a dashed line. And then it doesn't matter to me where you label it, but you got to have that x equals -1. Okay, so then your vertex is -1, 4. Find the y-intercept. It's on the table, but remember, your y-intercept is also your c value. So you can write it as 3 or you can write it as 0, 3. You cannot write it as 3, 0. Okay, so you can write it as 3 or you can write it as 0, 3. Okay, and then state the range in stat builder notation. Notice it only says the range because what is the domain? All real numbers. So this is going to be y such that if it's opening down, it should be less than or equal to. If it's up, you flip it, and then you always look at the y coordinate of your vertex. Okay, so it should always be that y coordinate of your vertex, okay, is going to be that highest point there. All right, questions for me on number 1. Okay, so all your points are below the value of 4, okay, that vertex point. Okay, for number 2, it says we are going to compare f of x to the quadratic function g of x that's in the table. We have to find which one is the greater maximum, and then you have to explain that. In your explanation, okay, there are going to be a few things I'm looking for. Okay, one is I want you to identify both max values. Okay, so these notes are to help you understand what I'm looking for when I'm grading. So when I'm grading your test, I'm going to look to see that you have both max values and that you state how much greater one is in units. Okay, so this is exactly how we practiced it in our note. That's how we went over it on our homework. So those are going to be the 2 things I'm looking for. So in your table, there's a couple different ways that you can find your maximum. One way, if it's a maximum, it has to be the biggest number. Okay, the other thing you'll notice is the points on either side should be symmetric. Okay, so this is going to be your maximum. This is your max value at 3, 1. And we are going to be looking at the y coordinates. Okay, to find your maximum for f of x, you are going to use x equals the opposite of b over 2a to find your x. So -6 over 2 times -1, 6 over -2 is 3. And then to find your y value, you're just going to plug that back into f of x. So -3 squared plus 6 times 3 minus 15. Okay, and you can do that with either mental math or you can use your calculator. You are going to have your calculator for that. So either way is fine. Okay, and then you do 9 minus 15, so you should get -6. So your maximum here is 3, -6. Okay, so this is your max here, this is your max here. So all we have to do is look and see which one is greater. Okay, so they called this one g of x in the table. Is 1 greater than -6? Yes. So we say g of x has the greater max value. Okay, and we're going to make sure we list that value as the greater max at 3, 1, because how many units above -6 is it? 7. And I said it was 7 units above f of x's max, because I was running out of space, which is at 3, -6. Okay, so identify both your max values, say how much greater one is in units. So g of x has the greater max, 7 units above f of x's max at 3, -6. All right, and then number 3. So for number 3, we did this in 3.1. If this is one that you are struggling with, I do recommend that you watch part of the notes video. Okay, there's a video that has like 2 of these examples in it, me going over them. So it's really important, if you're struggling with that you hear that explanation again. We're also going to go over this one together. So it says last year an electronics store sold 200 refurbished phones, and the cost of each one was $350. This year, the manager is considering reducing the price to increase the sales. So for each $10 decrease, the store is going to sell, oh sorry, I wanted to make that yellow. The store is going to sell 40 additional phones. So now that's orange, so we'll make this green. All right, so it says how much should the store charge for each phone to maximize its profit? Okay, so we are going to be finding the maximum values, and then we have to find the domain and range in context of this situation. The reason why they say in context is usually your domain is all real numbers. That's not going to be the case for this. Okay, so the whole thing about these is the profit, the revenue. To find how much they're making, the revenue consists of the price per phone multiplied by the number of phones you sell. Okay, so we have to come up with an expression for each one. One has to do with the price, one has to do with the number of phones. Okay, so we guys look at your 2 because I'm going to ask you guys to help me a little bit with this one. Okay, and then RJ, can you pick out what you use for the price?
I said 200 plus.
Okay, so with the price one, the 350 is good because that's going to be the money part. So we're going to start with that. The other one that has to do with the money is going to be the $10. So when you guys are determining how to group them, we're going to group the price part together and then the phone part together. Okay, and sometimes it's a decrease, sometimes it's an increase. Okay, so Emerson, if it's a decrease, what am I going to put here? Okay, so I did minus, and then what did you put with it? Yeah, 10x, okay? So the x is going to go with the decrease in the price. Okay, and then for the number of phones sold, Jack, can you tell me what you put for that one?
I put 200 plus 40x.
Okay, and so why was that a plus instead of a minus this time?
Because added.
Yeah, so they're doing the additional phone. So if they're selling more, it'll be plus. Okay, if there's a price increase, then we've done examples where they decrease. So just make sure you're paying attention to your context. So this is going to be your equation here. We're going to FOIL that out, and then we're going to put it in standard form. Okay, so I feel like you guys have been doing a really nice job with the FOIL. Oh, thank you. And minus 400x squared. Yes. Okay, so you have the 40 additional and then the 200. And then from there, you can combine your like terms. Okay, so you're going to have a quadratic equation here that you can find the maximum value of. Okay, so once you have this, the whole goal is to be able to solve for x so that we can plug it back in to find the price. So when you are trying to find the value for x, you are going to use the opposite of b over 2a. So in this case, your a value is the negative 400. You always find the a value in front of x squared. Okay, so you have negative 12,000 over 2 times negative 400. Okay, and we should get a positive value for this. So when you divide, you get 15. Now remember, that is not your answer of how much they should charge. It doesn't make sense. You're going to drop the price from $3.50 to $15. That's too good to be true. So what do we do with that? Well, remember, we already came up with an expression for the price. The price is $3.50 minus 10x, and then all you have to do is plug in the 15. So $3.50 minus 150 is 200. So what should they charge? They should charge 200 for each phone. Okay, and then for part B, it says find the domain and range in context. So with the price and the number of phones sold, we know that they can't be what type of values? Negative. So if you want to start both of these like this, you can. All we have to do now is find what our upper bounds are. So for the x, what we're going to do is we're going to take our two expressions because we're doing this in context. We know that the price has to be greater than or equal to 0. Okay, so we know that whatever the price is, it has to be positive. So we can solve that for x. And then did you guys get 35? X is less than 35, so that's going to go here. Now, when you do the other one, because the number of phones sold, that has to be positive. Remember what always happens with the other one? What kind of value do you get? Yeah, you get the negative value. Okay, and then because that's not in context, you end up with x is greater than or equal to negative 5. Okay, that's where you have to edit it because it can't be negative. Okay, so the lowest value it could be for x is 0, the highest value it could be is 35. Okay, for your y value, to find what the biggest y value is, you just have to plug 15 into your equation. And again, that's something that you can do with your calculator. Okay, and then after you substitute, you should get 160,000. And that is going to be the second part of your range. Okay, how did this one go? Good. Okay, and it's okay if you had to do your notes to do this. What I would do is I would either, you can try to recreate this one again, or you did have a few in your homework as well. So that can be some fresh problems for you. All right, and then let's go to page 2.